Welcome back to part 5 of the Procedural Rock tutorial series. This is part of the Magic Market series in which we were responsible for creating the environment assets. So in the last part we created our material for our rock, and it's going to be what we bake out using a bake texture and use on our low poly rock in conjunction with our displacement. So we have displacement, roughness, and our diffuse. And so once we've baked out those textures, it would be good to be able to generate this for multiple variations of rocks. So we're going to be doing that in this tutorial by using a top network. From where we left off last, we can go ahead and jump to our out network. And currently we only have our single bake texture. This one is the one for displacement, and we can just name it accordingly. So displacement bake. Cool, so let's also drop a new bake texture, and this one's going to be for our diffuse and roughness. So we can call this diffuse, roughness, bake, and in here we need to do a few things. So we know that our UV object is our low res geo, so we choose low res geo. Now our high res object is not actually the high res object. We currently have our material on this high res preview. So what we can do is hide that, and on our high-res geo, just go over and select a new material for it, and that will be the rock shader. Once again, returning to our outnet, we can now use that. So under high-res object, just choose high-res geo. For output picture, we're going to do something very similar to the displacement bake. So inside of our textures folder that we have created, we can go ahead and create a new file. So let's call this rock. _ percentage sign, open brackets, channel s _ percentage sign, open brackets, udm d.rat. Cool. So now we have our path set up. Let's go down to the image planes that we want. And once again, we will extract the format as EXR, not Targa. We can then go down and choose specular roughness, so spec rough, as well as diff color, so diffuse color. Then we can go over to advanced, and over here we would like to just choose the candidate objects and the force objects as we've done before. So candidate will be high res and low res, force will be high and low. Cool. So we're now forcing them and we're only using those two. Great. So we can actually test this out now. If we render to disk, this should take about a minute or two. And you'll notice that it has to first generate the rock geometry. So that's a bit of a step that actually takes some time. It needs to generate the high-res rock, and because it has to do that, it takes some extra time and it is more resource intensive, and we'll get into that shortly. But for now, you can see in your render scheduler that it is baking out your diffuse and roughness. So there we go. It took 2 minutes and 43 seconds, and what we end up with is a diffuse map that looks like this, and a specular roughness map that looks like this. So now we have our two maps, and it took 2 minutes and 43 seconds. Now we can decrease the time on that. If we go down to baking, we're currently using 16 samples. And we can drop this to something like 4 samples, open up our scheduler, and try rendering that again. So you can see now that it took 1 minute and 26 seconds, and the resulting image looks largely the same. So no problem there, you can reduce under your baking samples. So we can do the same for our displacement bake. Let's also drop the samples on here to something like 6. And now let's go apply those textures to our existing low res geo so that we can get an idea of how this looks. So here's our low res geo, and I'm just going to adjust the camera to sit right here. And we know that we have a material for this. So on the material palette, we have this rock displacement preview. We can also just plug in our two textures that we have. So that's base color. So you're choosing your diffuse color over here. And for roughness, we're taking the specular roughness, going over to surface and just changing this to white so that it doesn't tint our base color in any way. One thing that we didn't actually do is rebake our displacement texture. And it's actually important to do so because the material that we've created actually contributes to the displacement. So our moss has some displacement to it. So let's also just render this one to disk. And we know that this one doesn't take very long. It used to take about 15 seconds, but now that it has to take the material into account, it'll take a bit longer. So it took 45 seconds. We can go to our object level. And now our rock has its displacement. And let's take a look at this when we render it. So when it renders, what you'll notice is that you have what you'd expect, except for some of this moss appearing at the bottom. Now this is actually an issue where it doesn't detect anything in a particular area, and so it makes a bit of an averaged guess as to what those values should be. Now to fix that, it's similar to what we did to fix the artifacts in our displacement bake. You go down to your diffuse roughness. Under your ray bias, you just increase this value. So we'll do 0.05. Once again, you can just render this out. Now if you render again, that should fix the issue of our moss appearing at the bottom of the rock as well. Cool, so this is actually our low-res rock that we're rendering, and it looks decent. So now the next logical step for us would be to take this and put it into a TOPnet. So let's just hide our display geo and go ahead and drop down a TOPnetwork. We can rename this top to rock compiler and dive inside. The first thing we're going to do is drop a wedge node. This is incredibly important to tops. What this does is it generates wedges. So a certain number of wedges. Each wedge has attributes, and those attributes can be fed into a particular network and adjust the output for each wedge. So what does this mean? Well, let's say we have 3 wedges, right? So we just set the wedge count to 3. We then decide that we're going to create a wedge attribute. And this attribute, we're going to actually use this in our rock generator. So let's call this scalar. So scalar, let's also make it a vector. So it's a float vector called scalar. Over here, you'll see that we have a start and end range. Now, by default, this will generate 3 wedges, and the values will be 0, 0.5, and 1. So it will evenly increment the value up, right? So you have an even distribution of the value scalar for wedge number 1, wedge number 2, and wedge number 3. And we can actually view this. If we right-click on our wedge and say generate node, it will generate those 3 wedges. So if we middle mouse on a particular wedge, you can see the scalar vector over there, 0 on every axis, 0.5 on every axis, and 1 on every axis. However, we can also generate random values for each of our wedges, which is very useful. We just say random samples, and if we right-click and say generate node, once again, you'll see that we now have random values. So each one is a random value. So it no longer does the whole thing of an even distribution. It now does it like this. So the cool thing is we can now use this to control the scale of our rocks. So if these are considered X, Y, and Z values, then it's as simple as setting this up to be perhaps a value of 0.8 as the lowest possible value and a highest possible value of 1.5. So each wedge will generate a value between 0.8 and 1.5 for every axis. Now, if we right-click and generate, each value will be between that range. To actually use that value, we need to first feed this into a ROP geometry output node. So we drop one of these, plug the wedge into it, and on this ROP geometry node, we need to go choose our SOP path. So let's go ahead and navigate to our rock gen, and we have our low res out, right? We want this to generate the low res out. Because remember, we're not outputting the high res, we're only using the high res for displacement purposes. So as an output file, we can actually save this somewhere. So how are we going to save this? Well, let's create a new folder. We can call it geo. Inside of geo, we can make a new folder called rocks. And over here, we'll just save our rocks. So we can call it something like low res underscore rock dot. Now, you may be wondering, how do we output each rock with a different value? Because you may know that if you output a sequence of frames, you would do something like $F and then the file type, so .bgeo.sc, right? This will give you a sequence of files, and each one will have the frame value. But we don't want a frame value. We want each wedge index, right? We want wedge 1, wedge 2, and wedge 3. To do that, all we have to do is replace this $F that we would usually use with backtick at PDG underscore index. and then we backtick again to close it. So what this does is it finds the @PDG index attribute, and we can use that to generate our rocks. So if we say accept, you'll notice that we get an error. And it's just saying that the PDG index was not found. And this is a common thing. You need to generate this node for it to be happy, right? It needs to generate, and it will find this wedge. And then it will say, okay, I have found PDG index from wedge. So cool, I'm happy. So now we want to actually use our scalar attribute somewhere. So we want to use it in our rock gen. Now the cool thing is we've told this ROP geometry node that in low res out, we're going to be looking for wedge attributes. So we can go over there, and anything above low res out can use that scalar attribute. So on our rock generator, all we have to do over here under our geoprep is replace this with @scalar dot and the axis, so .x. And I'm also going to just set this display flag to our sphere so it doesn't have to reset every time. We can do @scalar.y and @scalar.z. So you'll notice that all of these values are brought in as 0. And that's because there is no default wedge value, right? It defaults just to 0. So we can't get an idea of how this looks anymore because we're now filling in these attributes. And this is a syntax that you won't really see anywhere else, where you feed in into a parameter. So this is @scalar.x. And what this will do is it will fetch this from our wedge node. Under scalar, for each wedge, it'll fetch the value. And then we can output each rock using the ROP geometry node. So let's give this a try. Let's right click on our ROP geometry node, and then we can say dirty and cook this node. And it'll ask you if you want to save, just say okay. And you can see with these 3 circles that it is beginning to generate those 3 rocks, right? So for each wedge, it's generating a rock. So the cool thing is that this is actually a distributed render. So what that means is it can do 2 at a single time using multiple cores. So once that's done, you can go up a level and drop down a geometry node, and we'll just call this top preview because we want to see what our TOPnet is generating for us. So go inside and drop a file node and just choose the low res _ rocks, and it will assume that this is actually $F, which it isn't, but we can still use that to view our rocks. All right, rock 0, rock 1, rock 2. So you can see there's 2 shapes that are fairly similar and one that's very different. Now you'll also notice that these 2 have the same faceting, right? If you focus on that edge over there, you can see that the faceting is the same. And with this rock, the faceting is actually the same, but there's no geometry there. So we also want to change our faceting in our TOPnet. So to do that, we can add some attributes to our wedge. So let's go ahead and add a few attributes. Let's do a facet _ frequency, and we'll give us a range between 0.7 and 1. And then let's add another wedge attribute, calling this one something like large _ noise _ offset, so that we can offset our large noises by this value. Our range will be -100 to 100. We can do the same for a small noise offset, so small _ noise _ offset. Once again, a range of -100 to 100. All right, so once we have all of those, we would like to randomize their samples. So let's randomize all of these samples. And now if we right click and generate node, you'll notice that even the values that have the same range end up with different values. So each attribute has its own seed, which is very cool. So now we can go ahead and use those. So in rockgen, we created a couple of attributes. And now that I'm back in here, let's also create one for amplitude. I think that'll be cool. So one more wedge attribute. One more called facet amplitude. Cool. And this one can just be between 0.7 and 1.3. Go up a level on our rock gen. We can now start using this. So let's use our facet amplitude first, facet _ amplitude. And let's go ahead and use our frequency. So @facet _ frequency. And you can actually get a very interesting look if you choose to turn your facet frequency into a vector, because then you can have different facet frequencies on each axis. So you can have almost a shearing effect on your rock faces. So we won't be doing it for this part. We can copy over this @facet frequency and paste it into every one of these. All right, so under frequency, we can go ahead and also use our large noise offset. Large _ noise _ offset. Once again, we can copy this and paste it into each one of these. You can just press tab to switch between them. That's the fastest way. Over to stepping, we can also use our large offset noise for this. So once again, Control V, but this time we'll multiply it by a value. So just do ×3 for each axis. And the cool thing about this is that because it's an offset, you can use the same one and just multiply it by a value. So ×3, and the last one ×3. Once again, returning to facets, let's also do this for our small facets. We'll do an offset of @small_noise_offset, copying this for each axis. And then for stepping, we can do the same for our small stepping. Cool, so we've now used a few attributes that we've created in our TOPnet, and we fed it into our rock generator. So if we decide to, once again, output some geometry from this, we can just right-click on our ROP geometry node. Now this geometry already exists. So if we try and run our ROP geometry node, nothing will happen. It'll detect these files on disk and then just not do anything. So we have to say delete this node's results from disk. And then we can say dirty and cook this node. And once again, we can just wait for it to generate our geometry. Cool, once it's done, let's take a look at our new rocks. And you can see that each one is now very different. This first one is quite flat with not much faceting. The second one is quite long with some faceting. And this third one is tall with a lot of faceting. So that's quite cool. We now have a rock compiler that randomly generates our rocks. And the reason that my facets actually increase per rock is because I forgot to switch on random samples. So it went from 0.7 to 1.3. So just switch that on over there. We'll use that for our next set of rocks. So we can delete this node's results from disk, and we can also just generate the first node. Now we want to also output our textures with this, right? The textures are dependent on the rock. Each rock has its own type of texture. So what we're going to do is use a ROP fetch node. We're going to put this down over here. And this is actually a really cool node. You can call in any other ROP and have it generated by tops. So let's go ahead and select our ROP path. We'll go to our outnet and choose our displacement bake. Plug this into the displacement bake. So once we've connected our ROP geometry to our ROP fetch, there's one thing that we need to do before we output this. And you may be able to guess what that is. Because we have 3 separate rocks, we need 3 separate textures, right? However, our current ROP, if we go to it over here, just generates this. It'll generate this 3 times and overwrite it each time. So to avoid that, we need to feed it an attribute that can track which index number it is, very similarly to our @PDG_index. So we can go over to our out network, and over here in our displacement bake, after this rock, we can just put underscore, and in here, we'll do a backtick @wedge index backtick. Now what that would do is output something like rock _1 _ displacement, so on and so forth. And then it'll do the same for rock 2 and rock 3. So we can also do that for our diffuse and roughness. We can just put rock _backtick @wedge index backtick _ and the rest of it. So if we go back to our object level, we can now actually begin on outputting our displacement with our geometry. So just right click on this node and say dirty and cook this node, and it will generate everything above it as well. So it'll ask if you want to save. Once again, just say okay, and it will begin on outputting our textures and our geometry. When that's done, you should end up with 3 different rock displacement maps. So for me, this is rock 1, this is rock 2, and this over here is rock 3. So you can see each one generates a different displacement map. So let's take a look at the rocks that they generated. Cool, so we now have our 3 rocks that have been generated. Once we have that, we can go ahead and add our next ROP fetch. Alternatively, if you want to, you can actually just add it on your bake texture. On your displacement bake under images, you could add the specular roughness and diffuse color onto this and just do it as one ROP fetch. But I do like the option of having them separately, because then you can control the settings separately. For example, if you wanted a higher resolution displacement, you could do that. So for this tutorial, I'm just going to duplicate this ROP fetch, and in the second one, the ROP path will be the diffuse roughness bake. One other thing is to just change the generate when on these 2 ROP fetches to all upstream items are cooked. So cooked just means it's finished, it's done its job. Generated just means that it's calculated the necessary wedges to begin. So all upstream items are cooked, that way we can begin one after the other. Okay, now you will notice that when you render with this, it can become quite RAM intensive. Now, if you're using anything less than 32 gigs of RAM, you're going to run into some issues. So what you can do on your rock gen, inside of your rock generator, you can actually bypass this over here, where we subdivide and ray. You could, instead of doing that, simply run the intersection clean, and you could even add a switch node over here, so just a switch right here, and then just switch between the two. So let's say we have the high resolution, which is the rayed version, and the low res, which is the intersection clean. So we can now switch between these two, right? So input 0 would be the high res. So let's rather swap these around so that input 2 is the high res. From here, what we can do is once again bring up our parameter interface. And under geoprep, we're going to add that switch node. So just drag the select input under your geoprep folder. And we can rename the label to something like high resolution. And with this, you'll be able to switch between a fairly fast low-res version and the subdivided high-res version. So even inside of your intersection clean, you could even change the target size over here to 0.015 on the remesh. And all of that will speed this up. It will speed it up and make this less resource intensive. So of course, once you have that, you can bake out your texture from here. I do remember that I did in fact forget to attach the roughness ramp back in here. So let's just do that. And I'm going to make one change on here, just increase the roughness on both of these. Cool. So, everything's now plugged in. Right. So the other thing before we finally bake this out is we can maybe increase our wedges. So let's test this out with more wedges. Let's do 6. So the other thing that I was considering is perhaps making our rocks not as tall, because all of our rocks tend to be quite tall. So we can do 0.5. And remember, it goes X, Y, Z, and W. There's actually W on the end over here, so we don't actually use that. But this second value is Y. So we'll do 0.5 and 0.8. And let's change the random seed. One thing we'll need to do is just delete the geometry that has already been generated. So let's just say, delete this node's results from disk. And just double check to make sure that this was removed, because sometimes it actually doesn't work and I'm not sure why. I'm not sure if you have to say generate first and then delete, but sometimes it doesn't delete from disk. And when it comes to the ROP fetch node, it actually won't delete them from disk because it doesn't know what file it's saving out, right? This is dependent on another node. So you can delete these by hand, but they actually just get overwritten. That's not really a problem. I'll delete them on my side anyways. Okay, so we've basically got a fresh start. So now we can just right click on our second ROP fetch, dirty, and cook this node. And we'll need to give that some time, but we should end up with all of our geometry and all of our textures. All right, so that was maybe, I think, 8 minutes or so. We've generated our 6 rocks with their 6 displacement textures, as well as 6 diffuse and 6 roughness textures as well. I'm going to warn you, these textures are pretty low res because I went for the very low resolution version, with my high resolution toggle being set to 0. And actually, let's turn that into a toggle. That's more fun. So high resolution, integer, you can change it to toggle. Very nice little thing you can do. Toggle, apply, accept. High resolution, on and off. Super cool. So keep in mind, these are low res. It's 1024 resolution textures, as well as a very low resolution rock that the displacement was baked from. Once again, it's not a hero rock. You can, of course, use the high res to make somewhat of a hero rock, but these are basically scene fillers. So of course, you can try baking out a lot of much better rocks, but for the sake of this tutorial, I'm just keeping it low res. So let's go over to our material network and just drop down a principled shader. Because we'd like to take a look at this. We can just call this preview, and over here, set base color to white so that it does not tint. We can go to our textures. Base color texture, we'll be using this rock diffuse 0. So this is for the first rock. For our roughness, we'll be using our rock 0 spec rough. And we'll also push up our roughness under specular just to 1. Under displacement, enable texture displacement, rock 0 ds. Effect scale of 1, offset of 0, and then apply that to our preview. Great, so one low-res rock completed. And this would be great for something like a game asset or for distant rocks. I wouldn't suggest using this close-up. As you can see, the resolution of the images really does give away that this is a low-res rock. You can also add further things that will help this out a lot, like a bump map. So I would suggest doing a bump map with just a basic noise with a very high resolution, so it adds very fine bumpiness to the rock, and you would export that as a normal map. So yeah, that's one rock done. But we have all of these other rocks. Now, of course, the material won't work for all of them because we've set the material to just be for rock 0. But as you can see, we've got 6 different rocks, right? From 0 to 5, and each one is different. So in the next part, I'm going to show you how you would use this in Solaris, how you can turn all of these into a single USD asset with all of their materials applied. It's a very nice method because you can turn this into a USD and have access to all of these different rocks, and all of them will maintain their textures. So I will see you next time with the final part of the Procedural Rocks series. Thanks for watching. Bye.